Class 11 Chemistry. Hello students, this is your Archita ma'am. Today in this presentation I am going to discuss part 2 of the chapter 1, that is some basic concept of chemistry. In part 1 we have already discussed many new terms. Now in this we are going to discuss some more new terms. So let's start. First term is stoichiometry. Stoichiometry deals with the calculation of masses, sometimes volume also, of the reactants and the products involved in a chemical reaction. Before understanding how to calculate the amounts of reactants required or those produced in a chemical reaction, let us study what information is available from the balanced chemical equation of a given reaction. The balanced chemical equation is given. Methane is reacting with oxygen to give carbon dioxide and water molecule. Here, one molecule of methane reacts with two molecules of oxygen gas to yield one molecule of carbon dioxide and two molecules of water. Methane and dioxygen are called reactants and carbon dioxide and water are called products. The coefficients 2 for O2 and H2O are called stoichiometric coefficients. Similarly, the coefficient for methane and carbon dioxide is 1 in each case. They represent the number of molecules and moles as well taking part in the reaction or formed in the reaction. Thus, according to the above chemical reaction, we can say 1 mole of methane reacts with 2 moles of oxygen to give 1 mole of carbon dioxide and 2 moles of H2O. Or we can say 1 molecule of methane reacts with 2 molecules of oxygen to give 1 molecule of carbon dioxide and 2 molecules of H2O. In terms of volume also we can say 22.4 liter of CH4 reacts with 44.8 liter of O2 to give 22.4 liter of carbon dioxide and 44.8 liter of H2O. So this mass, mole and number of molecules are interchangeably can be used while talking about the particular balanced chemical equation. Now let us move to new topic, limiting reagent. Many a time the reactions are carried out when the reactants are not present in the amount as required by a balanced chemical reaction. In such situation, one reactant is in excess over the other. The reactant which is present in the lesser amount gets consumed after some time, and after that no further reaction takes place whatever be the amount of the other reactant present. Hence, the reactant which get consumed limits the amount of product formed and is therefore called the limiting reagent. In the given slide, the burgers or we can say pizza is being made, and the excess of reactants are also left over, by which we cannot make further burger. So the limiting reagent in a chemical reaction is a reactant that is totally consumed when the chemical reaction is completed. Now we would discuss the concentration of the solution. A majority of reactions in the laboratories are carried out in solution. Therefore, it is important to understand as how the amount of substance is expressed when it is present in the form of a solution. The concentration of a solution or the amount of substance present in its given volume can be expressed in many ways. Some of the ways are mentioned in the slide. Grams per liter, which is given by mass of solute by volume of solution. Next is molarity, which is given by moles of solute by volumes of solution. Next is parts per million, which is called ppm, units of solute by 1 million units of the solution. The next is percentage composition. It is the parts of solute by 100 part of solution. Now let us discuss some one numerical based on this limiting reagent. Aluminium is reacting with hydrochloric acid to give aluminium chloride and hydrogen gas is being evolved. So the question is being asked, if 25 gram of aluminium was added to 90 gram of HCl, what mass of hydrogen will be produced? First case, which is being shown, 25 gram of aluminium, if we see, we get 2.78 gram of hydrogen, and from 90 gram of HCl we get 2.47 gram of H2. So the H2 produced by the reaction of the 90 gram of HCl is lesser compared to the H2 produced by the 25 gram of aluminium. Hence we can say HCl is the limiting reagent. Now we would see the expressions of the different concentrations of the solutions. Molality, which is called M. Some of the expressions we have already completed in this slide. Now some more expressions are there for the concentration of any solution. Molality, designated as small m, is given by moles of the solute divided by kg of solvent. Mole fraction of solution is given by mole fraction of solute, which is moles of solute by total moles of solution, and similarly the mole fraction of solvent is given by moles of solvent by the total moles of solution. If we sum up the mole fractions of the solute and solvent or any component present in the solution, the summation will always result to 1. Again, new term for the concentration of the solution is formality. Number of formula masses of solute dissolved in 1 liter volume of solution is called formality. Now formality is expressed as mass of solute by formula mass of solute into volume of solution in liter. And if we are considering the volume of solution in ml, then 1000 should be multiplied in the numerator part. Molarity and formality is having the same formula. Molarity is for the molecules which have independent existence or which can be isolated. Formality is for the crystalline molecules like sodium chloride, etc. Next one is normality, which is designated by capital N. It is given by the weight of solute in grams by equivalent mass into volumes in liter. If we find out the relation between normality and molarity, we would get normality into equivalent weight is equals to molarity into molar mass, or we can say normality equals to molarity into valency. And if the solution is acidic or basic, then it can be written as normality into molarity. Normality equals to molarity into number of H plus or OH minus ions.